After we learn about sigma notation in the normal general mathematics, so how can we implement that concept, that notation into Riemann sums? Okay, and then we learn that through a simple example here. So imagine we are approximating the area under the graph of here fx equal y of square root of x for the range between x equal to 0.5 to x equal to 3.5. And as you can see, it is already highlighted in the graph here, shown here. And say we decide to do that by writing the expression for right Riemann sums. Okay, this is the right Riemann sums with 4 equal subdivision. So how can we express this using summation notation? So remember, it's a right Riemann sum, so we divide it into 4 equal subdivision. So in that case, we can do it this way. So then the total area under the curve can be expressed as A1, area of the first rectangle, plus A2, the second rectangle, area of 3, the third rectangle, and area of 4, the fourth rectangle. And you see here the pattern is very similar to the pattern with the flop when we learn about sigma notation. So actually, A1 plus A2 plus A3 plus A4 can be simply written as the sigma from I equal to 1 until 4 for AI. Okay, and let's go into the details. So this is the general concept of how can we express the Riemann sum using summation notation. Now let's go into a little bit detail. So how can we actually do this? Okay, remember that the range is from x equal to 0.5 to 3.5, and it's divided by 4 equal subdivision. So what does that mean? Is that we'll have delta x there. Okay, what will be? It will be 3.5 minus 0.5. That's the initial, divided by 4, which is 3 of 4, which is plus 0.75, which is shown here. That's the first, is delta x. And then we know that the fx is y equal to square root of x. So we can write that as, so now as follows. So fx then equal to square root of x. Okay, and then since this is the right Riemann sum, so we will look into this one. Okay, this x. So basically this is the x1. Okay, so that is the x1. This is x2. This one is x3, and this guy is x4. Okay, it's the right Riemann sums. So we can then express the xi equal to 0.5, okay, plus 0.75, which is delta x, times the I, and then fxi then equal to, okay, we insert this term into this equation, then we get this expression. So the next, we know that the area of rectangle I equal to the width, okay, which is delta x, and the height, which is the fxi. So we can express that into, we can substitute the value. So this is the delta x, and this guy is actually the height, the fxi. Okay, and then we sum the 4 rectangle. So the sigma, remember the sigma, the one that we learned from the previous slide. So this is the sum of the 4 rectangle, and we can then just substitute this one into this. So this is the sigma notation of Riemann sums for expressing the area under the curve of fx equal to square root of x from 0.5 to 3.5 using four equal subdivision, for rectangle with equal subdivision. Okay, so next let's summarize the step. So the first step, what we did was like, first we need to define what is the delta x. Okay, that's very important, and delta x is b minus a equal to n. So this is for, of course, for the range of okay, from a to b. Let's say it's delta x equal to b minus a. Then the second step, we need to define what is the xi, what is the expression for the xi. Okay, in that case, for the right Riemann sum, so this is for the right, okay, Riemann sum, that's equal to a plus delta x times I. Okay, and the third step is to define fxi. So what will be the fxi, the height of the rectangle, and that is actually equal to delta fxi, and the area is equal to delta x times fxi. And finally, we sum the rectangle on the right sum. Okay, it is I from this is for the right Riemann sums, and the one on the left is for the left Riemann sum. So we need to remember the four steps. This is step number 1, step number 2, step number 3, and step number 4. So let's practice for this exercise. Let's say we want to approximate the area between gx equal 5 over x plus 2 and the x-axis on the interval of 1 to 7. So this is the interval 1 to 7. Using a right Riemann sums with 9 equal subdivision. It is already illustrated in this problem. In case you are not given the illustration, you should be able to do that yourself. So what expression that represent the approximation? So remember the step that we've learned from the previous slide. So the first thing, we need to define the delta x. So that's step number 1, I would say. Step number 1. So what is delta x? The delta x then equal to, remember, b minus a divided by n. B is the right range, the maximum, a is the minimum, and n is the, how many division is that? So in this case we have from 1 to 7. So this is 7 minus 1 divided by 9. So this one then equal to 6 over 9. This one equal to 2 over 3. Yeah. The second step, then we need to define xi. So then xi, in this case, you see here, this is our x1, and this is our x2, and this is our x3, this is our x4. So what is xi? Xi then, so we start from it's 1 plus, okay, it's 1 plus delta xi, delta x equal to 2.2 over 3, 2 over third I, that's delta x. So next is, we can easily then define what will be the gxi then equal to 5 over xi, and xi we can substitute, so that one is 1 plus 2 over 3 I plus 2, and we know the ai. The ai equal to gxi times delta x. It is equal to, then we have a gx So this one I will try to simplify it by multiplying with 3 on the numerator and denominator. So it's 5 times 3 equals to 15 in this case, and 1 times 3 equals to 3 plus 2i plus 2, that's the top term. So here then we can rewrite that one, that's equal to 15 divided by 3 plus 2i plus 2, okay, times delta x, which is 2 over that. The final step is to write the sigma form, so which is in this case this is the right Riemann sums. So it starts from from I equal 1 to x. Remember, it's the because we have a 9 rectangle, so it's to 9 ai. So ai is basically this term, the one on the top, 15 divided by 3 plus 2i plus 2 times 2 that. That's all.